Welcome. Thanks so much for joining this session today. I will be talking about the boosting your analytics with machine learnings for SQL Nerds, so specifically SQL Server Nerds. All right, so I'm going to start with a question. How many of you have used SQL Server before? Hopefully all of you. All right, how about R? Yeah? Have you tried SQL Server and R before? No? Okay, no, this is actually good because this session is intended to be a beginner sort of session to give you a bit of a taste of what you can do with SQL Server and R and how easy it can be and the kind of tips and tricks that you want to watch out for. I want to also understand as well, how many of you come from database developer background? Okay, so some of this is going to be applicable to you. BI, analytics, yeah. DBA? DBA, okay, cool. All right, so perfect. All right, so I currently work at Microsoft as a program manager. I am specifically in the business analytics area for the Azure Data team. So in the Azure Data, it includes SQL Server and Azure SQL DB, SQL DB, and whatnot. So there are quite a few services out there. And the goal is we really want to be able to enhance customer experience and grow the business. So much like other businesses out there, right? So I'm in that specific dedicated team. So what I have learned as a program manager, working with other program managers, we always want to understand about essentially how the products are being used, how can we make the customer experience much better, and we use data for this, and business knowledge as well, and customer engagements. I want to talk about a little bit about the book. Sorry, this is a shameless plug on the new book that Thomas Kastron and I have worked on. So this is SQL Server 2017 Machine Learning Services with R. So some of the concepts in this book is actually applicable for SQL Server 2016 as well. So if you are from the database developer sort of background or DBA background or BI background, you want to know how to use SQL Server and R and how to take advantage of it. This is a good book to get started. So in this book, I talk about how to use some of the features like polar base, column store index, how to use it together with R so that you can make the most out of it. And some of the chapters, Thomas actually really drilled down into the actual concept of R, why R is useful, and how to get the most out of R as well, and some of the functions or the libraries that you can use to make the most out of R. All right, so the agenda today is the first one is why machine learning and how you can operationalize it, and what the story is like, how challenging it is. Some of the tips and tricks, and then just one slide on the resources. So how many of you are embarking in some sort of data science or machine learning projects? Yeah. What's the use case for in your scenario? Like, how do you want to use it? Is it for insurance maybe, or for predicting something?
It's kind of like a predictive analysis.
I see. How many of you today have a spatial data science team to do this today? Not many? Wow, this is a good chance to learn, I guess. So I want to give a shout out to the Coursera website. There is a really good course by Johns Hopkins University. If you are getting started and really want to get into data science, that's a good one to start, because it gives you the foundation of the mathematics side of it, and then it builds your R skill, and then you can apply it with your business knowledge and your database development side of it. All right, so let's talk a bit about machine learning. So as a program manager, or you can think of it as an entrepreneur or business owner. Essentially, there are a couple of things that you really want to do well. One is delighting customers, and you can obviously do this by creating really appealing products and services, and there are many of them that are like that. So when you think about Netflix or Spotify, they obviously use data to be able to delight their customers. You want to also be able to, get better engagement. So imagine if you contact like tech support or contact billing or whatnot, you hope that they will be able to know and pull out information about you so that you don't have to explain everything from beginning to end, right? And then another one is I mentioned a little bit about Netflix before. So as an example, you want to be able to create intelligent solutions to enable differentiation. So businesses today, they have a lot of competition. So that's why everyone's sort of going after the ML side of it, either to improve the customers or come up with a new product. All right, so I want to go to the next section here, which is related to operationalizing machine learning. So I think I saw a couple of people put their hands up on the R side of things. Just want to give a really quick background on R. It's actually a really old language. Some of you may know R back in the day from the data mining concept. Do people here have people here heard of data mining before? Yeah, there's SSAS, data mining before as well, right? So it's coming back. And there's a good reason it comes back, because as we talked about earlier, there is really strong use cases about being the leader in the industry. You want to offer good products to your customers. So the good thing about R, and this is one of the reasons why I love using R, it's actually really easy to use, and the community is quite big. So whenever you go online, you search, there's rbloggers.com, there's analyticsvideo.com. They talk a lot of the use cases that people have asked. So a lot of the things that you wanted to know, most of the time, the answers are already out there, and you just have to tweak it here and there to fit it in your use cases. The ecosystem is pretty good. Like it says here, 10,000 plus packages in CRAN. So it's really amazing. And now Microsoft also offers Microsoft R Server as well. So that actually really helps in packaging with SQL Server that I will talk to you about later this session. Yes, go ahead.
Why would one choose R over Python?
Ooh. So from my personal, this is a personal answer.
I have no idea.
This is a personal answer. It's because I haven't actually gotten run to test out Python as much. So I don't. Yeah. So in some cases, Python is actually faster to do the calculation than R. And then if you want the fastest, one of the fastest sort of ML language, it would be Julia. Unfortunately, I won't be able to give personal experience on how they work. So I'm just gonna stop right there and go search it online. All right, so in terms of data science projects, what would it look like if I take out all the kind of business requirements, all the kind of discussions with the businesses and how to apply it, essentially from a really technical sort of data person perspective, this is what you'll have to work with. So from our script, you will have to somehow retrieve some data set, do some data munging, so that means you transform the data so that it fits well, and then you train your model, and then you produce a predictive model that you can use for scoring, essentially. So this is roughly what the iterative process looks like. So before I go ahead, I'm going to just show you what R looks like. If you go online out there and then search, hey, show me the best R IDE tool or R IDE out there. And most of the time, people say RStudio because that's been around the longest. If you're a Visual Studio person, there is an extension called RTVS, so R Tools for Visual Studio. It's actually quite powerful, but you want to use the Visual Studio 2017 version because the 2015 one is a little bit flaky. So what I've got here is the Visual Studio 2017 version. So I'm going to show you how simple it is without going too much on the R side of things. So on the top two lines here, I hit Control-Enter, and then on the bottom, it's just essentially showing what has been executed. What I'm doing here is just calling the two libraries, ggplot2 and coreplot. That's actually just for plotting for the visualization side of it. If you are learning R, and you will stumble across this a lot, there's a very popular data set. They actually call it data frame, but from SQL world, it's just like a data set or table called empty cars. So this empty cars is just a variable that stores that information. To assign a variable or data set to another variable, it's just, it looks like a little arrow here. You can also use equals, but I prefer to use this because sometimes you might confuse the equals for the comparison logic versus actually really assigning a value. And then R is actually really good for statistics. So if you want to do the calculation just to understand what does the distribution look like in my data set A in this example, this tells you or calculates all the important things like the minimum, maximum, first quartile, third quartile. It's like very basic but really important statistics distribution. So this gives you really quick understanding. As an example, if you want to do predictive modeling as an example, and you want to look at which column should I use as an input to your predictive model, you probably don't want to use the ones that always look uniform or have a lot of null values, right? So this gives you a quick sort of view. Okay, that looks like it's varying a little bit. I can probably trust that column. I can probably use that column. So this is kind of like a quick peek at the variable. And there are also a couple of really good graphical function. And this one here is the standard one called plot. Essentially what I'm doing here is I'm just saying, hey plot, hey R, please plot all the variables or the columns that I have and how they relate to one another. So the empty cars that I set here is just contains a list of cars with the miles per gallon and then the horsepower and the number of cylinders, etc. So here it sort of roughly shows you how one variable has some sort of relationship with another. So it's very hard to see. Sometimes it can be useful and a good starting point, but we can go to other functions that are more useful. So this next couple of lines, they're actually coming from the library core plot. So let me execute this. Click Control Enter, and then you can see on the plot here, I'll just make it bigger. Now, miles per gallon to miles per gallon is the same variable, so obviously it's going to show that it has strong relationship because exactly the same number, right? So miles per gallon to cylinder, red means going the opposite direction. So you can kind of say, well, if the miles per gallon, let's just put it here. Okay, so another data set that you will actually hear a lot is the IRIS data set, the SQL Server MSDN or books online. The documentation online actually uses the IRIS data set as part of the examples. So here I'm just actually using a really simple function called qplot. And this sort of visualizes the relationship between two variables for different species. So whenever you work with data in a data science project or any analytics project, likely you will need to understand more about what data you're working with. And then sometimes it's using the statistics summary, like the one that I show you with the summary function. Or sometimes you really need to use data visualization so that you can clearly, the patterns really pop. So this is one way that you can use R. All right, so I will show you a couple of things that I think is quite handy in RTVS or in Visual Studio. There is a pane here called Variable Explorer. So let's see. Right. So over here, I actually have the list of variables that I have defined from A to M to my data. And then I can expand this further to see the schema of that variable essentially. So because this is a data frame, data frame is similar to data set or table, I can see the list of all the columns that are included in that variable. And I also can click Excel, so it just pops right out to Excel, so you can see what the data looks like. So it's pretty neat in that perspective. Let's see if I can switch to a real example of how I would do training a model for predictive analysis. How many of you like frozen yogurt or ice cream? Do you usually have toppings on your frozen yogurt? Yeah? Okay. How many of you like Avengers? Come on, there should be more of you. I was so excited about when the Avengers movie came out. So anyway, yes. Anyway, so the demo today, I've decided, I had a spare weekend. I really wanted to put together a quick application where I can predict, based on a photo, whether someone would likely buy frozen yogurt with their toppings. So, and I give this a go. So I'm going to walk through the basic bits, and then I'll show you what the application looks like. All right, so let's make this a bit bigger, that way it's easy to see. All right, so the top part is just kind of like, hey, if the library is not here, or if the package is not installed, let's install it. So I'm going to skip that because I've got the package installed already. And then the first couple of lines here is really calling a library and then trying to establish the connection to SQL Server. So like I showed you earlier, if you extract the skeleton of the data science project, you would need to extract some sort of data that you're going to work with. So this is exactly what I'm doing. I'm actually connecting to SQL Server and then extracting the data out of SQL Server into R. So R uses memory a lot. What that means is I've got my connection here established now. The data set with 4 columns here that I'm going to use as training data set, I'm putting it into R. So if I shut down my laptop, open it again, I wouldn't have that data anymore because everything is stored in memory. So that's something to remember. And the larger data set that you work with, so imagine, I don't know, 1 million of rows, 10 million of rows, my little laptop probably wouldn't be able to scale. So this is kind of like the challenges using R. So the next couple of lines here is just me creating a logistic regression model. So likes toppings, this variable here, essentially is the output of the what I want the model to do. And then the input is just like a simple math equation. It's age, gender, so is female, and then the emotion ID, which is the higher the emotion value, it's the happier you are. So it's pretty, actually pretty easy to write. But the challenge here is not about just putting all the variables that you have as input and then hopefully you get the best. It wouldn't work like that. You kind of have to experiment, choose which columns you want to make sure that you can reduce the bias towards the training data set. And how many people here are really good with statistics? Okay, cool. So please correct me if I'm wrong. So essentially, what I have here is I've called a summary to the model that I've created using the logistic regression model. So here I've actually got the values of essentially evaluating the values of the input variables. And the lower the z-score, it's the more significant the input variables that you are going to use for the predictive modeling. So I'm going to stop at that because that's kind of like the basic thing I could say, just to explain in terms of why these columns are, or these variables are useful for my model. Plus, I only have these 3 columns. So from my perspective, when I tested this, okay, the z-score is actually low enough, it's statistically significant, I'm going to use this, and that's fine. Obviously, you can iterate more and choose, well, maybe it's not all the 3 variables, maybe it's just the 2. There's actually a process for this, and the Coursera course that I mentioned earlier actually talk more about how to do that. So assume that I have done all the kind of like combinations of choosing the models that I like or that actually make sense. Assume that I've skipped that. I can do the evaluation here. So I'm going to just quickly run it. Let's see, up to here. Up to here. So generally speaking, this is just to give you a taste again. In a data science project, you want to test what how the model is doing. And you want to also draw what I call ROC curve. Let's see if it's showing. Not yet. It should show here. So the more you get into data science and R and predictive modeling, the more important like this kind of analysis. So if it was a straight diagonal line, some of you actually who have used SSAS data mining, this might look very familiar. The closer it is to the diagonal line, or actually the diagonal line itself, it's actually kind of representing a like a random chance. So your input variables that you use for the predictive modeling doesn't matter. It's just kind of like random chance. But the closer to the top left, the better it is. But you have to be also careful that the model that you have built is not biased towards just that test data set. And that's why there's a reason for doing repetition in terms of testing, just to make sure that your model is not biased towards that just specific test data set. All right. So now the question is, assume I've got my model that I like. Where am I going to store this? If I'm working with an application developer, how do I give it to them so that they can use it as part of, say, for example, an application that predict the topping for the frozen yogurt? So it's really challenging. In the rest of the script, I'm just going to skip a few, and then I'm just going to show you towards the end. What I've done here, like I've mentioned before, if I shut down my laptop now and start again, that model is gone. So sure, 40 rows, I think it was 40 rows or so. It took a few seconds to determine the model. But if you have 1 million of rows that you have to do predictive modeling, chances are it's going to take a couple of hours maybe. So, and that model will be gone once I shut down my laptop. So that's not good, right? So here, what I've decided is I'm going to store that data in a binary format and store it inside SQL Server. So that's what I've done. But there's more. I will pause right now and go back to the slide deck. Let's see here. Any questions?
What part of it is machine learning?
In this instance, I am not using much of the machine learning side of it. I'm just using the predictive modeling. When you get really, really smart, you would be able to actually build something that actually determine what are the best sort of input variables, as an example, to use. So I'm kind of sort of skipping that part a little bit and jumping straight to assuming that it's already created. So here are the challenges of using R, and I've mentioned some of this before. It's the data movement bit. So as an example, if I'm using the 1 million of rows as my input variable, I have to move it all the way from SQL Server to my R server and then do that calculation. And then moving that data carries security risk. So as an example, what if that data is super sensitive and only certain people can look at certain data set? So it makes it challenging. I mentioned earlier, like, how do I call this R script or this model from my application? And then on top of that, the scale and performance side of it, right? So I wouldn't be able to just use my laptop, and you might actually need to have a dedicated server with a large number of RAM, as an example, just to keep it going. So what I showed you in terms of the script earlier is I've done this part here. I've created the model, and that's it. The challenge is I will have to work with the application people, and then I'll have to somehow think about how we're going to separate the service or embed the logic so that the application can kind of call it in case there's new data that they want to do, that we want to do for prediction, right? So it's really challenging. So when we think about this data movement, it looks a little bit like this. We're moving from one data set, from SQL Server maybe if you're lucky, or maybe you work with CSV and whatnot. It's like moving data here, there, and it's just really confusing. Essentially, it's becoming really messy. And then some of you are probably familiar with this. Portland traffic, Seattle traffic is bad too. That's where I live now. there's always bandwidth issue. So imagine if your data set actually lives all the way somewhere in SQL Server, and it's and you have to get the data through the network and back to your R server, and it's just gonna get too much. So what should we do? So if you extract some of the challenges that we have, it's essentially in a lot of the cases that we've seen, a lot of the intelligence, like predictive, the predictive sort of capability, lies in the application itself. Whereas in fact, the intelligence part of it usually have to work with data. So Microsoft has decided to add R services in SQL Server 2016 so that we can bring the intelligence closer to the database itself. And then in SQL Server 2017, that ML capability has been expanded, so it has we've added another language, which is Python. So you can choose whichever flavors that you want. So some of the things that we solve with the SQL Server ML services is reducing this the movement. So in production environment, when you do the predictive modeling, hopefully you don't have to move the data around for real-time prediction, as an example. And then deploying R scripts or models, if you want to share it amongst your team members or different teams and whatnot, it should be really easy to do. So imagine if you have to do some sort of HADR solution, you don't have to worry about moving one script to another. It would hopefully be just copied across. The model has been automatically copied across. And on top of that, you can achieve this enterprise scale and performance. So remember that SQL Server 2016 and 2017 have got this column store and all this interesting performance capabilities. So for a lot of the data transformation, you can leverage SQL Server side of things before you bring it into R, so that R can just do the computational side of it from statistics or from data visualization or predictive modeling that it actually is good at. So what does that mean if you want to use SQL Server and R from kind of like database developer perspective, or even DBA or BI person? So you would still need to develop most of your scripts in R IDE. That's my recommendation. Just because, say for example, you use SSMS and you want to embed R script inside SQL or T-SQL straight away, it's really challenging because there's no IntelliSense and it's harder or a bit slower to iterate. Whereas if you're using your favorite R IDE, so as an example, RStudio or RTVS, you can iterate really quickly and it's really mature. Then once you're happy with that script, you can extract the core part of it, and then use it to do the model, training the model inside SQL Server. And I'll show you that in a minute. And then once you do that and have the model stored somewhere, your production application would call the SB execute XML script or a wrapper around it to do the prediction. So generally speaking, I like to abstract the application call to the SQL Server or database with a kind of like a stored procedure layer. And then that stored procedure can call the SB execute XML script. And so by doing that, it makes it easier for you to transition the models or change anything in the backend, and the application is separated or abstracted away from all that intelligent complexity and versioning. How many of you today are using database project in SSDT? Cool. So you can actually add this as part of your database project. You can do, how many of you do continuous integration and continuous deployment today? Cool. So you can exactly do that. In the book that I mentioned earlier, in my book, I actually went through the step how to do that, where you have a database with predictive modeling and whatnot in VSTS. You can actually achieve continuous integration and continuous deployment to test how well your models look like over time. It just plugs in as if it was just your database project as part of the CI/CD environment. So the powerful bit is that SQL Server and its environment, if you already have an established and mature process, this R bit, this R capability in terms of predictive modeling, just makes it easier. It just kind of like enhance it even more. So if you're using SQL Server 2017 and you're just, you have a separated environment, I'm just a database developer, I don't work with data science stuff, my data science colleague can do that, and they just give me the model in binary format and I store it in SQL Server. You don't even have to use the SP execute XML script anymore to do the prediction. You can call it natively using the predict syntax, and I'll show you that in a minute. Okay.
Julie, you have a question over there?
Yeah, so in the vanilla version of R, you're constrained, your working data set is constrained to the size of your RAM. But I saw some comment on one of your earlier slides about being able to work with large data sets. Is that not a constraint anymore?
So that's correct. So the question is, the challenge with the current R, so pre-SQL 2016, is that you're constrained with the memory. So when you use SQL Server in R, there are a couple of advantages. So if you are doing a lot of the data munging and the transformation, so SQL Server can do that much better than R in most cases, most cases, especially with large data set. So you don't need that memory to do that transformation, so that's one. Two is there is also resource governance within SQL Server that can help to do with the parallel processing and capping some of this, the work that R will be doing inside. So does that answer the question?
Sure, yeah.
Yeah. The third one, if that's not good enough, there is a RefoScale R, and they have a lot of, the RefoScale R package, they have a lot of good scalable R functions that are meant to be able to handle multiprocessing. So that's the key. And SQL Server can actually leverage that RefoScale R. The predict function, it works with a lot of the RefoScale R functions, and it does a lot better in terms of like performance-wise for batch mode. So that's also another advantage. All right, any other questions? Okay, how many of you are familiar with SQL Operations Studio? Okay, so this is SQL Operations Studio. There's a reason why I'm not using SSMS today. I love using SSMS, but there's just one tiny bit that I could not do in SSMS. So I'll show you why. All right, let's just go through this script first. I can move this. It looks like it doesn't let me. Never mind. All right, so make sure that I can connect. Great. All right. Whenever I execute SP execute external script, I like things to be tidy. So this is kind of my preference. You can do your own way of doing things. So essentially what I'm doing here, I'm saying that I'm going to use the language R, and the script, the R script that I want to execute is in this variable R script, and then the input data set that I'm going to pass into the R script is in a dynamic SQL format in @SQL script. So that makes it easier to explain, right? And then on top, what I've done here is I define what that SQL script, essentially the dynamic T-SQL statement, that will let me get or extract the input data set. So here it's just, I'm going to the sales.orders. Essentially let me just read here, this. Essentially what I'm doing here is just getting the monthly order count and order amount by salesperson in the year 2015. So that's what this long, reasonably long SQL script is doing. And then the next type now, this is the hairy part. This is the R script part, and you'll get used to it over time. What I'm doing here is it's slightly long and not, maybe more complicated than what I showed you here as an example, where I just say, I call plot and that's it, it's displayed. It's because the IDE actually supports for it. But because I have to kind of like move the representation of the image around, I have to set things up first. So I call the library, and then I'm going to work with JPEG file format. then what I have here is the input data set. So this is the monthly order count that I've got from SQL Server. I can refer it as input data set here. So this is how R represents that data. And then what I'm doing here is just saying, I want to analyze it for the salesperson, Amy, Jack, and Hudson. Technically, I don't have to do that. Maybe if I want to analyze everything. And technically speaking, when you want to do this kind of filtering, it's probably best done outside of R and do it in SQL. But there's option of doing this. And then what I'm doing here is just calling the qplot function to draw it, and then I'm transferring the data set of the image back to output data set, which is what I'm going to see as the output of the SPExecute XML script. So see how it has the result set, plot for binary max? So this is the result set of that output data set. So if I run this, it will give me some gibberish, which I won't be able to see or understand. But if I go to this View as Chart icon, I can choose Image. And then here, let's see if I can zoom out a little bit so you can see. There you go. So it actually gives me a JPEG file of the R script that I've done. It's sort of like creating a plot here. So this plot here renders just some binary representation of the image, the same thing as what it does here. So this is one thing that I could do in SSMS. So it's quite good. It's really easy. And see, like there's an outlier here. So Hudson is the top performer. So that's why data visualization is good, because it can call out a lot of outliers, sometimes much more easily than just looking at numbers. All right.
Julie, is that actually writing a JPEG file out to the file system, or is it just creating a binary result that you're visualizing?
So it would have to write it somewhere in a temporary sort of location first, within the memory during the execution. Once it's passed it out to SQL Server, that's it. That temporary file is kind of gone. That's why I had to set it up here.
Yeah. Okay.
Yeah. Otherwise, that part could have been skipped too. All right. Okay, so let me go to here. Oh, actually, there's one more that I haven't showed. All right. So let's see if this runs. Great. Okay, so this is my data set that I work with, the sample data set from the frozen yogurt that I mentioned earlier. And this is what it looks like when I have to call the prediction, the predictive values. So I've stored the model somewhere, which is in the Froyo model. I call the top one in this case, because I just want to use one of them. Sorted by the creator date. So it's the latest model. And I want to predict the likelihood of people buying the toppings if the age is 20 and it's female and reasonably happy. So this is how I would do it. So the R script looks like that. So in R, to comment things out, you have to use hash. So if I was still debugging this, and this is one of the reasons why I say that if you do the training and all that and testing in SQL Server using R, it might be a bit slow, because you would have to iterate this over and over again. There's no IntelliSense. And then you might have to do the kind of like debugging output. And it's a bit more natural when you do it in RID. So you don't want to put any of the debugging output in production environment, because it slows it down. Whenever there is a debugging output, it has to print somewhere, right? So imagine if you have to execute it 1 million times. You would have to print 1 million times. So you don't want to do that. So what it's saying here is there's a 89.57% chance of a 20-year-old female reasonably happy with buy toppings on their frozen yogurt. If you're a database developer, you couldn't care less about the data sciencey bit, but you just want to use the model. So it's super easy. So I'm just getting the latest model, and then I'm calling the predict function here. And then I just pass the model that I have earlier to predict the 20-year-old reasonably happy person. Super easy. And you can do this in batch as well. So at the moment, I'm just showing you as a single row. So you can have multiple rows from a table or from queries and whatnot. You can pass it here, and I'll just return the results in a batch mode format. And the predict function is much better. As I said, it's better in terms of the batch execution. And then what you do is you can wrap it up in a stored procedure. So instead of the application developer seeing, the SB execute external script or the predict function, you can just wrap it into like a stored procedure like this. So essentially, your application would just call an exec function, and that's it. An exec stored procedure. So
Will you be able to call this model, the predict, through the CLR, SQL CLR?
So
In case I want my application to call through a CLR stored procedure.
yeah, it's possible. So I would imagine that your C# code or something like that, or maybe VB script and whatnot, your C# code would actually need to understand how to pass in the kind of the R model, and then, it's a little bit complicated. We can talk offline just to understand the scenario, but it is possible, yeah. All right, let's see. Okay, so just to show you a bit of a comparison, this is my script that I went around to kind of do the training, right? If I want to do the, productionize this, I wouldn't just copy this across, put it into SQL Server. It just wouldn't work, and it wouldn't be efficient either. So I would kind of extract the key pieces that I want to do. Okay, so I actually extracted the key pieces. So I'm extracting the fact that I want to create a model, I want to serialize it, and then I want to, this is optional, but this is what I'd like to do, to understand the accuracy of that model itself, and I store it as part of when I enter it in the model. So remember I mentioned earlier, I have this VSTS going that does the automated build. Whenever I store this, I can also compare, was this performance with this recent deployment has a better model than the previous one, as an example. So it's one of the reasons why I did this. It's optional again. Yeah, so it's much shorter. I extract the key core, component of it. But likely, if you want to determine the, which variables to use and all that, you kind of want to do it outside of SQL Server, just to make it easier. All right, let's see here. Okay, so essentially, I love looking at new houses, especially the kitchen, because it always looks clean. And to me, sometimes looking at the SQL Server and R and how you can neatly put things together, it just reminds me of just clean kitchen at home or the open house and whatnot. It's super nice. So the model training, so the stored procedure that I showed you earlier happens here. And then if you want to do the prediction, it can also happen here because of the SQL Server and R services or ML services. And so that the application doesn't have to know anything about the logic inside model training or the scoring, and it'll just call the prediction side, and that's it. It's super easy. So, all right. Let's see. All right, the SB execute external script pattern. So this is a common pattern that I've seen so far. Whenever you call SB execute external script, chances are you'll be doing a couple of very common things or two common paths. So you will always put the input data set into our computation. That's usually given. And then you might do just a small little tiny bit easy data munging or transformation. Hopefully you do it before. And then you either do the training the model, or you do prediction modeling and outputting some sort of data visualization. So that's kind of like the kind of skeleton side of the patterns in terms of SB execute external script. All right, so a bit of demo. I mentioned earlier about frozen yogurt. So that was me a while back. It says I would likely 86% by toppings on my frozen yogurt, which is pretty true. Mr. Bean, any guesses?
72%.
72%? It's actually 15.
Really? Wow.
Yeah.
That's
I haven't checked with Mr. Bean, by the way, but
yeah.
this is what the application says. All right, Shirley Temple.
By definition, he is an outlier.
All right.
Oh, yeah.
Very
maybe,
close.
Yeah, sure.
Yeah. All right. So if you want to test this, I'm going to do it here now from my phone. So send an email to me and attach a photo. So attach it, don't embed it, because my little application cannot handle complex things. As I said, it was an over a weekend project that I put together. So let me just send. So what I've done is I sent to myself a picture of Thanos, because I'm really interested. Come on, how many of you are Avengers? I see green, so you must understand what I'm talking about. And I didn't send the gauntlet. Yeah, it was a bit too much. It might destroy my app. Anyway, so yeah. So let's see how that goes. So what happens in the back end is, does all the fancy stuff. Then I've built this application. It's using Power Apps. Very simple to use. It has some good things. Yeah, and I managed to build an application that reads from my SQL Server. And it tells me, this is me apparently. I'm still 85.42%, so 86%, and it tells the images, the age, and the likelihood of buying the topping. So underneath this, my R script actually didn't do any of the cognitive services side of it. I've decided to outsource this, the calculation, the fancy calculation, to Microsoft Cognitive Services API. But R inside SQL Server has limitation in terms of calling an API over the internet. So I couldn't use it, so I have to resort back to CLR, which I thought was interesting because the gentleman asked about CLR. So I actually use CLR inside SQL Server to call Cognitive Services API and detect the age, gender, and emotion from the picture, and then pass it to R, where R already knows in numbers what the 3 values are and do the prediction. So that's what I've done here. So I'm going to do a bit of cheating. I've got 3 more characters that I would love to know. There. Oh, actually, Thanos has appeared. Apparently, he's age 46. And 12.57% likely to buy for your toppings. Let's refresh this. I grew up in Australia, so I have to do Thor, because Chris Hemsworth is from Australia. So this was Thor from the Dark World. His age is 40. In that one, it says 17.4% likely to. Okay, so the actor. Yeah. Yeah, because if you look at so if you look at the model that I use, it was really using the age, gender, and emotion, and it really depends on my sample data set, right? And my sample data set is somewhat skewed towards where the age and the gender highly contribute to the likelihood of buying toppings. So, and in fact, I sort of showed this earlier. So as I said, the smaller the Z score, I keep referring back to Australian way of saying things. The Z score for this is like much less than the other one. So that's in scientific, minus 0.6. So that's in scientific format. So this is like a much larger contributor to determining the likelihood of toppings. Could I have used just the gender, like the is female, that's it? Maybe. Again, it's based on the sample data set, right? All right. I briefly mentioned about this. So when you sent me an email, you were probably wondering what's the magic that brings it across the SQL Server. I'm not an application developer by trade, and I'm a program manager, so these days I try to, I like to put things together that it's really easy. So I use Microsoft Flow. When my email detects there's a picture, then it will send it to SQL Server. It calls SQL Server, it calls CLR to do the cognitive services, or to call cognitive services to determine the age, gender, and emotion. And then do the model training, and then do the scoring, and then pass it out to Power Apps. If you're an application developer out there, I'm sure you can do much better job than me. Again, this is a weekend project, right? While you're filling in the form and all that, just a quick one for the DBA. So this is probably something that you want to pay attention to. These are the two screens of how you want to set up 2016 versus 2017. So in 2016, it's just R services. In 2017, you have the R or Python option. You can install both if you want. That's okay. There is an SSMS custom reports that is available online that helps you to get going with R services. So what I mean by that is, especially in 2016, when you set it up the first time after you install it, there are a couple of things that you need to do, because sometimes the implied authentication might not be enabled, or even though it's installed, but the configuration is not done. So when you click on the View SQL script, it gives you all the script that you need to kind of tidy it all up for you. So that's my magic button. So you can think of R services as kind of like the external or extensibility framework inside of SQL Server. So the probably most common extensibility framework that you know of in SQL Server that you might have worked with is CLR. So R services is kind of like one of those. The cool thing about this is if you use SQL Server in R, I mentioned earlier before that you can control the CPU, memory and CPU affinity using the resource governor. And what else do I want to say? Oh yeah, the batch mode execution is super fast in SQL 2017. I've talked about the predict functions. I'm going to skip. There's a way to manage external library, so that's in 2017. R services in Azure SQL DB was kind of like something that we want to do in the future. If you're using the native scoring using predict function, just really pay attention to this, because it can only use the RX models, so using the RX function essentially, and you will have to serialize it, etc., using the RX serialized model in R, or the second or the third one here in Python. So it's meant to be really fast. So some of the do's and don'ts, I kind of mentioned quite a lot of this during the discussion today. So do the testing and all that. I have to stress this in your favorite IDE. And then do not run it as is, like I mentioned earlier. And make sure that you take advantage of the database itself, do the model management there. And leverage the best of the two worlds. T-SQL is usually good for transforming, querying, joining, and all that. It has in-memory, capabilities in SQL Server, so use that, and then use the R and Python bit to do the key function stuff, like, for example, statistical sort of analysis or predictive modeling. Then some resources that I think would be useful. Lots of tutorials out there. These are some of the ones that that are available from Microsoft side of things. But there are tons of websites out there that is useful, including the book. SB Execute external script. It's well documented out there. And then I have to give a shout out to my friend Thomas. He talks a lot about R in his blog. Really useful, and he gives like real world assessment of how good the product is or the function is. So I would really highly recommend you to visit his website to learn more. So with that, I'd like to say thank you for attending the session. Hopefully it's been useful. It gives you a bit of a taste of what you can do. Very simple, and sometimes it can be complicated too, but just to get you started. So thanks. Bye.